Hi everyone! Did you ever wondering why the fireworks are so pretty and why there are all different kinds of Christmas light? So we're going to spend a couple of days to talk about the colors and how that relate to different kinds of elements and how that relate to different kinds of energy levels. So we're going to talk about electrons, okay? And it's all because the electrons can cause those different kinds of colors. So we're going to explain why. Today we're going to go through electromagnetic spectrum and the energy levels. I'm going to talk about the detail. So Niels Bohr proposed this planetary model. He was saying that the electrons are orbiting in those fixed orbitals around the nucleus, and they have different energy levels. And people eventually figured out electrons can even move from different kind of energy levels. They can jump to a higher energy level, or it can even come back to a lower energy level. When the electrons move around different energy levels, it absorb energy, go to a higher energy level. It can release energy to go to a lower energy level. When it release energy going back, when it give away energy to us, we can see those kind of colors. Okay, different element can give away different amount of energy, so we can see different colors. How fun is that? Let's have a look. What does that mean by energy related to the color? Yeah. So the purpose for today's lesson is light is a type of electromagnetic radiation. And those kind of radiation contains energy. And different light or different color to us contains different amount of energy. I need you to take notes and write this down, please, on your notebook. This is the main information we're going to try to explain. Okay. First of all, light is a kind of electromagnetic radiation, or people call it wave. Okay, similar as the water wave in the ocean. Okay, but this one is kind of different too. Electromagnetic radiation is the transfer of energy by waves traveling through matter or even across vacuum, like an empty space. When there is nothing, no air, nothing, it can still travel. Okay, the waves that transfer this energy, we call them electromagnetic waves. There are all kinds of those kind of waves in the world. So we have summarized all of this, put them together. We call this an electromagnetic spectrum. I'm going to start from this left side. We're going to go through more detail. Okay, there are radio wave. That's why we can get radios, and we can listen to music. We can watch TV. Okay, and we even can get signals for the phone. Okay, and the microwave, you can warm up your food. Infrared is a type of wave that can help us to feel warm from the fire. You know, when we don't touch the fire, but we feel the warmth, it's because the radiation infrared. Okay, visible light is the light we see. Okay, different kinds of colors. Okay, UV, give us sunburn. X-ray is the one that we use in the airport for security, and the dentist use it to examine our teeth. Gamma ray is the one that we use for radiation therapy to kill cancer. Those are all different kinds of electromagnetic radiation, or we call those waves. Okay, you're sitting in your room, you don't feel it. There are lots of kinds of waves that are moving around. Okay, so if we zoom in, look at the visible light. The visible light basically is made of the rainbow color. Okay, people call it raw AGB. Okay, and it's the rainbow color, and different kind of color has different wavelengths. What does that mean? Let's have a look. What does it mean by wavelengths? Okay, wavelengths, people use lambda for wavelengths. A wavelength is talking about, think about water wave. Okay, similar as water wave, it has those different, like low area, high area. The wavelength is like between this crest to the next one. Okay, we call it lambda. And the unit, again, because we are talking about length, we use meter. Or when the wavelength is super small, we may use like nanometer or some kind of meter. Okay, and the traveling speed for this kind of radiation is super fast. It's in the speed of light. We use a small c to represent it. Okay, 3.0 times 10 to the power of 8. Again, this is called scientific notation. This 10 to the power of 8 means it's 1 and 10, 8 zeros. 1, after 1, there's 8 zeros. So this is basically 100 million. When we use 3 times 100 million, gave us 300 million meter per second. So from the sun to the earth, the light would come here in less than 8 minutes. It's super fast. Okay. Frequency is talking about, frequency is talking about the number of waves that pass an area in a given amount of time. When it has lower wavelengths, it's traveling, with higher frequency because it passed the area in a higher speed. I mean, in the same speed, but more waves will be in the same area. Okay, so how do we calculate the energy that the electromagnetic radiation contains? Okay, here's the equation. I'm not going to ask you to be able to use it. I just need you to understand. Yeah. So E energy in the wave or in the radiation is equal to a constant number. It's a huge number. We're not going to explain. Yeah. C is the speed of light. So H times C times this number and divided by lambda. Lambda is the wavelength. Okay, now let's think about the visible light. Okay. So we know that the visible light have different wavelengths. Okay. And when we divide by lambda, the longer wavelengths, when we divide by a bigger number, when we divide a number by a bigger number, this E would be smaller. Okay. And that means for the red color, it contains the least amount of energy. And then when lambda is smaller, like the blue and the purple one, it has lower, the shortest wavelength for the visible light. And when we divide a small number, E would be bigger. Okay, so that tells us this light contains the least amount of energy, and the purple color contains the highest amount of energy. So when we go back to the beginning, we understand that light is a type of electromagnetic radiation, or people call it electromagnetic wave. And those kind of light contains energy. It can transfer energy. Okay, a different light contains different amount of energy. The red color contains the least amount of energy. The blue and the purple contains the highest amount of energy. Okay, here you go.